Have you ever wondered what it really takes for a massive machine like the Boeing 737 MAX 7 to safely touch down on a runway, or how its powerful engines quietly and efficiently propel it thousands of miles through the sky? It's easy to take for granted the seamless dance of metal, hydraulics, and electronics that make every flight possible. But behind the smooth landings and powerful thrust lies a world of engineering precision designed not only to perform, but to inspire trust deep in the minds of everyone on board. Today, we're diving into that hidden world, focusing on the landing gear and engine systems of the Boeing 737 MAX 7, revealed through intricate 3D AI detail. Stick with me till the end, and you'll gain a new appreciation for the incredible technology that keeps us safely connected to the skies. The Boeing 737 MAX 7 isn't just another airplane. It's the newest, shortest model in Boeing's successful MAX family, engineered to be more efficient, quieter, and environmentally friendly than its predecessors. While it might look familiar to those who know the 737 lineage, under the skin it carries powerful innovations that make flying safer and more comfortable. What many don't realize is that this aircraft's ability to land smoothly or soar long distances depends heavily on two critical systems working flawlessly: its landing gear and engines. These aren't just metal parts bolted together, they are the result of decades of design, testing, and an understanding of human psychology, because every pilot, engineer, and passenger needs to feel confident and calm when the wheels leave the ground or touch it again. The landing gear is the plane's literal connection to Earth. Imagine the moment of touchdown. After hours of cruising high above, the plane descends and prepares to meet the runway. The landing gear absorbs immense forces, supporting the entire weight of the aircraft, which can exceed 140,000 pounds for the MAX 7. This moment is critical because the smoothness of the landing impacts not only the mechanical integrity of the aircraft, but also the emotional state of everyone on board. Humans have an innate response to landing. Our brains read the vibrations, sounds, and motions, forming quick judgments on safety. Engineers at Boeing know this well, so they design the landing gear to operate with precision, reliability, and even subtle noise reduction to ease passenger anxiety. The materials used in the landing gear alone tell a story of strength and resilience. High-strength steel and titanium form the core, chosen for their ability to endure extreme stress and repeated impact. Every time the plane lands, these components experience rapid and intense forces, yet they must perform flawlessly thousands of times without failure. The landing gear's hydraulic system controls the deployment and retraction of the wheels, a process that happens smoothly and quietly thanks to carefully engineered actuators and locking mechanisms. This isn't random. It's a symphony of mechanics designed to minimize surprises and maximize safety. Redundant systems and sensors continuously check the gear's position and status, giving pilots real-time feedback. This constant flow of data reassures the flight crew, who can trust that when they flip the switch to lower the gear, the plane will respond perfectly. But the landing gear is only half the story. The heart of the Boeing 737 MAX 7 lies in its engine system, the powerful LEAP 1 billion engines crafted by CFM International. These engines are marvels of modern aerospace engineering, built to deliver more thrust with less fuel and noise. Their large fan diameter and high bypass ratio make them exceptionally efficient, reducing carbon emissions and operating costs while providing the power needed for takeoff and long-range flights. The design also includes advanced noise reduction technology. This is no accident. Engineers are aware that the sound of an engine influences passenger comfort and trust. A smooth, steady hum signals reliability to the brain, helping to calm nerves during takeoff and cruise. What truly sets these engines apart is their intelligence. They're equipped with onboard diagnostic systems powered by artificial intelligence and predictive analytics. These systems constantly monitor engine performance, detecting even the smallest irregularities before they can become serious problems. This proactive maintenance capability reduces the chance of unexpected failures and improves safety. Moreover, the engines use a dual-channel full-authority digital engine control system, or FADEC, which ensures that if one control path fails, the other takes over seamlessly. This redundancy builds a psychological safety net for both pilots and passengers, a hidden guardian watching every revolution of the engine's fan blades. Together, the landing gear and engine systems embody the spirit of innovation that defines the Boeing 737 MAX 7. They are more than mechanical parts. They are the culmination of human ingenuity and psychological insight. Every bolt, sensor, and software line is designed with a clear purpose: to build trust in technology and create a safer flying experience. Understanding these systems not only deepens our appreciation for what it takes to keep planes in the air, but also connects us to the incredible minds behind the scenes who made it possible. By the end of this video, you'll see the Boeing 737 MAX 7 through a new lens. A marvel of engineering that merges metal and mind, technology and trust. So, stay with me as we break down these systems in 3D AI detail, revealing the hidden intelligence and precision that power every flight. It's a journey that every airplane lover will find thrilling, and every flyer will find reassuring. Ready to uncover the secrets behind what truly makes this aircraft soar and land with such finesse? Let's dive deeper into the landing gear, the unsung hero that carries the entire plane safely to the ground. The landing gear of the Boeing 737 MAX 7 is much more than a simple set of wheels. It is the foundation of every safe landing and takeoff, engineered to handle forces that are difficult to imagine. Consider this: when the plane touches down, the landing gear absorbs an enormous amount of energy. The aircraft's weight, which can be over 140,000 pounds when fully loaded, presses down on just a few tires at high speed. This impact must be softened and controlled to protect the plane and keep passengers comfortable. Understanding the landing gear means understanding the balance of strength, precision, and trust built into every component. At its core, the Boeing 737 MAX 7 uses a tricycle landing gear configuration, one nose gear in front and two main gear assemblies under the wings. The main gear features two-wheel bogies, each fitted with shock absorbers designed to absorb the energy from landing impact. The wheels themselves are made from specially formulated rubber compounds that provide maximum grip on the runway, especially during wet or icy conditions. This prevents skidding and helps pilots maintain full control during landing or taxiing. But what makes this landing gear truly impressive isn't just the materials, it's the technology behind its operation. The landing gear's ability to retract and deploy smoothly is powered by a sophisticated hydraulic system. High-pressure hydraulic fluid drives actuators that extend or pull back the gear, locking it into place within seconds. You might not realize it, but this entire sequence happens under extreme pressure, both literally and figuratively. When the gear retracts after takeoff, it must fit perfectly within the wing and fuselage cavities, minimizing aerodynamic drag while ensuring it can be redeployed instantly in an emergency. Pilots depend on the flawless performance of this system to reduce fuel consumption and maintain flight stability. What truly stands out in the MAX 7's landing gear design is the attention to redundancy and safety. Redundancy means that critical functions have backups, so if one system fails, another can take over without interrupting operation. The Boeing 737 MAX 7 landing gear features multiple hydraulic circuits, pressure sensors, and mechanical locks that ensure the gear stays securely in place once deployed. These systems are monitored continuously by onboard computers, which alert the flight crew immediately if anything is out of place. This multi-layered approach reflects a deep understanding of human psychology, knowing that pilot confidence depends heavily on predictable, reliable equipment that never surprises. The landing gear also incorporates shock-absorbing struts called oleo-pneumatic struts that cushion the touchdown impact by using compressed gas and hydraulic fluid. This ingenious design allows the gear to absorb shock smoothly rather than transferring harsh jolts to the fuselage and passengers. For passengers, this translates into a landing that feels controlled and gentle, even when the plane touches down on a rough runway. For pilots, it provides predictable feedback that helps them make real-time adjustments during landing. Beyond shock absorption, the landing gear has safety locks that prevent accidental retraction while the plane is on the ground. These locks engage mechanically once the gear is down, ensuring that even if hydraulic pressure drops suddenly, the wheels remain firmly extended. This prevents dangerous scenarios where the plane could collapse onto the runway during taxi or landing. This is another example of how Boeing's engineers combine mechanical reliability with electronic monitoring to create layers of safety that pilots can trust instinctively. Boeing also learned valuable lessons from previous generations, especially the 737NG series, when designing the MAX 7's landing gear. Engineers improved the ground clearance by adjusting the length and placement of the gear legs, allowing the MAX 7 to safely operate at airports with shorter runways or uneven surfaces. This flexibility expands the plane's operational range and opens new route possibilities for airlines, all while maintaining safety and stability. Every detail of the landing gear's design also reflects a psychological dimension. It must instill confidence not only in pilots but in passengers who rarely see it. The moment wheels touch down can be a tense time for many flyers, so engineers design for smoothness, silence, and reliability. Even small noises or vibrations can trigger subconscious alarms, causing discomfort or anxiety. By carefully engineering the gear to retract quietly and absorb shocks softly, Boeing helps create a calming effect that soothes the mind during critical moments of flight. The landing gear's tires are also designed with passenger psychology in mind. Their deep treads channel water away during wet conditions to prevent hydroplaning, reducing the risk of slipping. The familiar sight of spinning tires upon landing signals to passengers that the plane has regained firm contact with the ground, providing reassurance. It's a subtle but powerful example of how technology and human perception work hand in hand. In addition, sensors embedded in the landing gear monitor tire pressure and temperature in real time. This data is vital because tire failures can lead to dangerous situations on the runway. By alerting maintenance crews early, these sensors prevent small problems from escalating. This predictive maintenance capability reflects a shift in aviation from reactive repairs to proactive safety, a mindset that gives passengers and crew peace of mind before every flight. To sum up, the landing gear of the Boeing 737 MAX 7 is a masterpiece of engineering that blends mechanical strength, advanced hydraulics, and smart safety systems. It operates silently and invisibly beneath the aircraft, but plays a starring role in the safety and comfort of every flight. More than just metal and rubber, it's a system designed to inspire trust, backed by decades of experience and an understanding of how people perceive risk and safety. Every smooth touchdown, every steady rollout down the runway is a reminder of this invisible trust woven into the plane's very structure. This trust is crucial because the landing gear is the first part of the plane that physically interacts with the ground and, by extension, the passenger's sense of security. Knowing that this gear is built with redundancy, shock absorption, and real-time monitoring means pilots can focus on the critical task of flying and passengers can relax, confident that their safety is supported by the smartest technology and the most careful design. In the world of aviation, few systems receive as much scrutiny or require as much reliability as the landing gear. It is a symbol of engineering precision and psychological comfort, ensuring that every flight ends safely where it began, on solid ground. The Boeing 737 MAX 7's landing gear is not just a component, it is a testament to the quiet strength that holds up one of the most advanced planes in the world. The Boeing 737 MAX 7's landing gear might be the unsung hero of every flight, but the engines that truly bring this aircraft to life. The powerful heart that transforms fuel into the force needed to soar through the skies. At the core of this marvel are the CFM International LEAP 1 billion engines, a leap forward in technology designed to make flying cleaner, quieter, and more efficient. Understanding these engines means appreciating the incredible blend of physics, engineering, and psychology that makes every journey possible. The LEAP 1 billion engines are not just bigger versions of what came before. They represent a radical redesign with groundbreaking technology. One of their most noticeable features is the large fan diameter, about 69 inches, which plays a crucial role in the engine's efficiency. This large fan moves a huge volume of air around the engine core, a process called bypass, which reduces fuel consumption and noise. The high bypass ratio is key. More air is pushed around the engine than through it, which means quieter operation and less environmental impact. For passengers, this translates to a smoother, quieter flight experience, helping reduce the stress and fatigue that engine noise can cause. This reduction in noise isn't just a technical achievement. It taps directly into how humans perceive comfort and safety. Research in aviation psychology shows that passengers respond positively to softer, more stable sounds during flight. Loud, unpredictable noises can trigger subconscious alarms in the brain, increasing anxiety. By carefully tuning the LEAP 1 billion engines to operate at lower noise levels, Boeing and CFM have created an environment that helps calm nerves, contributing to a more enjoyable flying experience. The gentle hum you hear is no accident. It's the sound of comfort engineered. Beyond noise reduction, these engines are remarkable for their fuel efficiency. Advances in materials science allow the LEAP 1 billion to withstand higher temperatures, improving combustion and reducing fuel burn. The use of ceramic matrix composites and lightweight alloys reduces engine weight, enhancing overall performance. This means airlines can fly further for less fuel, reducing carbon emissions and making air travel more sustainable. This innovation aligns with global efforts to minimize aviation's environmental footprint, a critical concern for today's travelers and the planet alike. The true intelligence of the LEAP 1 billion engines lies in their advanced digital control systems. Equipped with a dual-channel full-authority digital engine control, or FADEC, these engines are constantly monitored and adjusted in real time. FADEC acts as the engine's brain, managing everything from fuel flow to temperature and thrust settings with incredible precision. If one channel experiences a fault, the other immediately takes over without interruption, ensuring continuous and safe engine operation. This redundancy is essential. as it builds a psychological safety net for pilots and passengers. Knowing that the engine's control system has built-in backups enhances confidence in the aircraft's reliability. Artificial intelligence plays an increasingly important role in engine monitoring. The LEAP 1 billion engines feature onboard diagnostic systems powered by AI algorithms that analyze data from hundreds of sensors. These sensors track parameters like vibration, temperature, and pressure, detecting anomalies that could signal wear or impending failure. The AI doesn't wait for problems to occur, it predicts them, enabling proactive maintenance. This predictive analytics approach reduces unexpected breakdowns and improves safety, making the aircraft's operation more reliable and cost-effective. It's a clear example of how modern technology integrates with human expertise to create smarter, safer flying machines. Thrust performance is another area where the LEAP 1 billion excels. Despite being lighter and more efficient, these engines deliver impressive power, allowing the MAX 7 to take off from shorter runways and fly longer routes without sacrificing speed or safety. This flexibility is vital for airlines operating in diverse conditions, from busy urban airports to remote regional airfields. For passengers, it means greater connectivity and convenience, opening new travel possibilities that were once challenging or impossible. The design of these engines also reflects a deep understanding of human factors. Pilots, for instance, rely on the engine's responsiveness and smooth throttle control during critical phases of flight like takeoff and landing. The LEAP 1 billion provides consistent thrust adjustments that help pilots manage the aircraft effortlessly. This reliability reduces workload and stress in the cockpit, contributing to safer flight operations. From a psychological standpoint, when pilots feel they have full control over the engine's behavior, their decision-making improves and their confidence soars, an essential factor in managing any unexpected situation. Beyond pilots and passengers, the engineers and maintenance crews benefit from the LEAP 1 billion smart systems as well. The AI diagnostics offer detailed reports and real-time alerts, making inspections faster and more accurate. This means planes spend less time on the ground for repairs and more time in the air, increasing operational efficiency. For airlines, that translates into better service and lower costs, but for passengers, it means fewer delays and cancellations, a win all around. Safety has always been at the forefront of engine design, and the LEAP 1 billion embodies that principle through every component and system. The materials used are tested to endure extreme conditions, from volcanic ash clouds to bird strikes, ensuring the engine can keep running even under unexpected challenges. The multiple redundancies, including fuel systems, electronic controls, and mechanical parts, work together seamlessly to provide a fail-safe environment. This complexity, while invisible to most passengers, offers a reassuring layer of security that aviation professionals take very seriously. In essence, the Boeing 737 MAX 7's engines are a masterclass in blending cutting-edge technology with an acute awareness of human psychology. The designers and engineers have not only crafted a machine that performs with unmatched efficiency and reliability, but also one that resonates with the subconscious needs of those who fly. The smooth hum of the engines, the seamless thrust adjustments, and the quiet assurance of advanced monitoring systems all come together to create a flying experience built on trust. The LEAP 1 billion engines are more than just mechanical powerhouses. They are intelligent, responsive, and caring components of the aircraft's ecosystem. They embody a philosophy that technology should serve humans, not just by pushing boundaries, but by understanding the feelings and fears that come with flying. Each element is designed to reduce anxiety, increase safety, and improve performance, creating an invisible bond between machine and mind. When you feel that gentle thrust as the plane accelerates down the runway, or notice the calm quiet during cruise, remember this is the result of years of innovation and psychological insight. The Boeing 737 MAX 7's engines aren't just pushing metal through air. They are delivering confidence and comfort to millions of passengers worldwide. It's a beautiful reminder that in aviation, technology and psychology work hand in hand, crafting an experience where science meets human trust at 35,000 feet.